Alright, this is a little introduction to logarithmic functions. As stated earlier, exponential functions are one-to-one, meaning they have an inverse. And this is the basic definition of a logarithm. You have y equals the log of base b, it's a base, it's a sub area there, of x the input, and that's the log definition there, where x is always greater than 0, so your input has to be always positive, and your base is always positive as well, and it's never equal to 1. Alright, now that is equivalent to this in the exponential form. So the input here is x, the output is y. So for log, that would be the xy ordered pair, right? So then if you switch those around, it should be this way for the exponential, and that's what we see here. See, the b to the y equals x. Normally it's written this way, right? F to the negative 1, which is the inverse of f, is written this way. B to the x. So that's y and that's x. But for our notation, the y output here is the y power here. The input here is the output here. So you can kind of see where they go. And we need to know where they go for transforming from logarithmic to exponential and going back from exponential to logarithmic. Okay? So here's the basic definition. F of x equals log base b of x. Now the key to understanding logarithms is what they produce. It's their output. What comes out of a log. Now, if you look back up here, the log produces this y value. But what is the y value? It's an exponent. See that? So they produce exponents. Okay, logs produce exponents. So the log of something is a number. That number is an exponent to the base. Okay, it's the exponent that the base needs to be raised to in order to produce your input, x. So let's see some different versions or different notations here. The first form over here is log form. The next form over here is exponential form. They say the same things, just in two different ways. This one says the log base 3 of x gives you 4. But this one says 3 raised to the 4th power gives you x. So to change this log to this over here, which is exponential, you'd start with the base of the log, which is 3, and then raise it to the output of the log. You'll notice this is the equal, so the output is the exponent, 3 to the 4th, and then it equals the input of the log. So 3 to the 4th equals x, the input. So the output's always the exponent, the input is the number it sets equal to when you change to exponential. So 3 to the 4th equals x. So this one, the log base 4, so we start with the 4, we raise it to what the log produced, which was 2, 4 squared equals the x. 4 squared equals x. Here the base is b, so we take base b raised to the 2nd power and set it equal to 25. B squared is equal to 25. So what we're doing here is we're going from log notation to exponential notation. They say the same thing, but see, sometimes you can figure out what the b is then, right? B squared is 25, so b has to be 5. And that's what this says. What number do you take to the 2nd power to get the input of 25 here? 5. 5 squared is 25. And you'll notice that it's producing the square. It's producing the 2. The exponent. It's giving you access to that exponent. So that's what logs do. They give you access to the exponents where normally you have no access to these guys up here. You can't solve for something like that. Alright, I moved down a little bit. I'd like you to try a couple here. Keep in mind now that the log base b of x, like that, can transform into b raised to the y value equals x. Now these are placeholders. They're just showing you where they go. I always circle my base, raised to my y, equal the input. Okay, see if you can pause here and try these two. Alright, here we go. This is how I would do it. 2 equals log base 10 of x. What would that look like in exponential notation? 10 raised to the output of the log equals the input. That's exponential notation, so my x actually be 100. And it says the log base 10 of 100 would be 2, because 10 squared is 100. It's getting you at the exponent. Over here, base b raised to the third equals 8. b cubed equals 8. So b would be 2, right? 2 cubed is 8. That's because it says log base b of 8 is 3. Some number base b raised to the third power is 8. Well, that number would be 2. That would give you that 3, that exponent. Okay, so now there is some more information here. If you've seen this kind of log base 10, they call this the common logarithm because it's commonly used. And you'll find that on your calculator, base 10. So normally we just write f of x equals log with a no base on there, x. It's kind of like the square root thing, right? That's a square root. It means the base, that would be 2 is the index. And if we want in other numbers, we put 3 for index, etc. Well, if there's nothing there, it means base 10. And your calculator has this one on it, log base 10. Okay? However, there's some other stuff too. Let's change from exponential now to logarithmic notation. So here what we are, we're in the 3 squared equals x. That's exponential. And we want to go to log. This is a little bit harder. But remember the things we have. We have the base 3, the exponent 2, and then the answer here x. So remember how this goes. It goes log base b of x, and you set that equal to y. It goes b to the y equals x. So see where things are placed here? Go backwards. I always start with the base. What's the base? 3. So I go, okay, log base 3. What's the exponent? 2. So it must be equal to 2. Logs produce exponents. And then the other number is an x, that goes there. That's how I create that. Same thing here. Look at this one. The base is e. The exponent is y. Logs produce exponents. And then the 9. And you can always check it. E to the y is 9. E to the y is 9. That's how you got that one. So I have 2 for you to try here. So pause the video. See if you can change these exponential notations into log notation. Okay? Base 10. Remember, base 10, we're just going to use just the regular log, right? So let me erase this. Give some room. Log base 10 equal to exponent. What's the input? X. Or log base 10 of x equals 3, right? Either way works. Alright, what about this one? Base b. Log base b. Exponent is 5. 30. Or log base b of 30 equals 5. Check it. B to the 5th equals 30. Yep. Hopefully you got those two right. Practice going back and forth. Create your own. Just create your own numbers and see if you can practice going back and forth and see if they make sense. Alright, look down here. We've seen this log base e here, right? Log base e was in the previous example, and that is called a natural logarithm. There's another key on your calculator, ln. So if you see the little sub e, log base e, we now write it as ln x, and that means this. So if you look at a logarithmic equation like this and you want to change it to exponential, you should think of a base e down here. So it's just a notation switch. It just means log base e. That's all it means. So my base is e. What's it equal? The exponent. What's it set equal to? E to the 6 equals x. So base e to the 6 equals x. I know it's a little challenging at first, but remember, this means the base 10, this means base e. That's all it does. There just means an e down there. Your calculator has that as well. So here are a few new ones with that base e. See if you can work all four of these out. Change these to exponential. Start with the e down here. Go to what it's equal to and then come back around, right? And then see if you can change these to logarithmic. You're in exponential. Write them out as logarithmic notation. So pause it, see if you can try some of those or think about them. And now I'm going to do them. Okay, so this one, remember this is base e. So I can even write a little e in there. E is the base raised to what logs produce equal to that. E to the 8th equals x. Remember that e is just that 2.178. Okay, here, e, what do they produce? Well, it's on the right side this time. E to the y equals 7. Okay. Alright, on here, we're in exponential. We want to go to log form. We want this. Remember, if the base is e, we're using ln now. We don't want to write log base e, we want to write ln. That's log base e, right? There's a little e there. What is it equal to? Well, remember, logs produce exponents, so maybe I'll set it equal to 3, and then the last thing left over is x. Or it could have been ln equals, ln of something. I got to put something in there. ln of x equals 3. And just check it. E to the 3rd equals x. Yep. Here, the base, 4. Or sorry, the base e. Natural log. What does it produce? Exponent. What's the input? 4. E raised to the y is 4. E raised to the y is 4. Correct.